a team of astronomers has developed a method that will allow them to see through the fog of the early universe and detect light from the first stars and galaxies. The researchers, led by the University of Cambridge, have developed a methodology that will allow them to observe and study the first stars through the clouds of hydrogen that filled the universe about 378,000 years after the Big Bang. Observing the birth of the first stars and galaxies has been a goal of astronomers for decades, as it will help explain how the universe evolved from the emptiness after the Big Bang to the complex realm of celestial objects we observe today, 13.8 billion years later. The signal that astronomers aim to detect is expected to be approximately 100,000 times weaker than other radio signals coming also from the sky, for example, radio signals originating in our own galaxy. Using a radio telescope itself introduces distortions to the signal received, which can completely obscure the cosmological signal of interest. This is considered an extreme observational challenge in modern radio cosmology. Their methodology, part of the REACH, Radio Experiment for the Analysis of Cosmic Hydrogen, experiment, will allow astronomers to observe the earliest stars through their interaction with the hydrogen clouds, in the same way we would infer a landscape by looking at shadows in the fog. Their method will improve the quality and reliability of observations from radio telescopes looking at this unexplored key time in the development of the universe. The first observations from REACH are expected later this year. The results are reported today in the journal Nature Astronomy. At the time when the first stars formed, the universe was mostly empty and composed mostly of hydrogen and helium, said Drive Aloy de Lira Aceto from Cambridge's Cavendish Laboratory, the paper's lead author. He added, because of gravity, the elements eventually came together and the conditions were right for nuclear fusion, which is what formed the first stars. But they were surrounded by clouds of so-called neutral hydrogen, which absorb light really well, so it's hard to detect or observe the light behind the clouds directly. In 2018, another research group, running the experiment to detect the global epoch of reionization signature, or edges, Pubble. The original result would require new physics to explain it, due to the temperature of the hydrogen gas, which should be much cooler than our current understanding of the universe would allow. Alternatively, an unexplained higher temperature of the background radiation, typically assumed to be the well-known cosmic microwave background, could be the cause, said de Lira Aceto. He added, if we can confirm that the signal found in that earlier experiment really was from the first stars, the implications would be huge. In order to study this period in the universe's development, often referred to as the cosmic dawn, astronomers study the 21 centimeter line, an electromag. They look for a radio signal that measures the contrast between the radiation from the hydrogen and the radiation behind the hydrogen fog. To do this, state-of-the-art techniques and technologies from different fields have been required. The researchers used simulations to mimic a real observation using multiple antennas, which improves the reliability of the data. Earlier observations have relied on a single antenna. He added, in essence, we forgot about traditional design strategies and instead focused on designing a telescope suited to the way we plan to analyze the data, something like an inverse design. This could help us measure things from the cosmic dawn and into the epoch of reionization, when hydrogen in the universe was reionized. The telescope's construction is currently being finalized at the Karoo Radio Reserve in South Africa. a location chosen for its excellent conditions for radio OBS. The REACH team of over 30 researchers is multidisciplinary and distributed worldwide, with experts in fields such as theoretical and observational cosmology, antenna design, radio frequency instrumentation, numerical modeling, digital processing, big data and Bayesian statistics. REACH is co-led by the University of Stellenbosch in South Africa. Even better understood is the late and widespread evolution of stars and other celestial objects. But the time of formation of the first light in the cosmos is a fundamental missing piece in the puzzle of the history of the universe. University of Cambridge. 2022, July 21. Astronomers develop novel way to see the first stars through the fog of the early universe. Science Daily. Retrieved July 21, 2022 from ift.tt/ZTNLSOV University of Cambridge. Astronomers develop novel way to see the first stars through the fog of the early universe. Science Daily. https://ift.tt/ZTNLSOV, accessed July 21, 2022. Thanks for watching. Please subscribe my channel for more videos.